In this video, I am going to factor this trinomial y to the power 4 minus 18y square plus 72. To factor this trinomial, the usual process or the method that we are familiar with, that kind of does not apply directly. We kind of have to play a little trick. The trick is this. Let's make the following assumption. We substitute the value u for y square. That means we are going to replace y square by u. Now u square is going to be y square whole square, which is y to the power 4. So we conclude that u square is equal to y to the power 4. Now I am going to take this value and this value and then plug it into here, because y to the power 4 is u square, so I am going to have u square minus 18 times y square, but y square is u, then plus 72. So by using substitution or by using u substitution, I have taken this trinomial and converted this trinomial into something new, which is something we are more familiar with. The method we kind of used here is called substitution method. Please do keep in mind that in mathematics, this type of substitution is extremely important and is very useful in proving many things. Now, let's go ahead and factor this trinomial. Look at the coefficient of u square, which is just 1, right? 1 times u square is u square, and then the constant term is 72. So 1 times 72 is 72, and I can factor it, by the way. Negative 6 times negative 12 is positive 72. Then if I add negative 6 to negative 12, that gives me negative 18. That's exactly what I have as a coefficient in the middle term, which is the u term. So let's go ahead and simplify it. So u square, now this negative 18u, I'm going to write it as negative 12u minus 6u. Then I have the positive 72. Now I'm going to create groups into this. I'm going to create two groups. So in the first group, I could factor out a u. If I factored out a u, is going to be u minus 12. In the second group, if I factor out a negative 6, that's going to give me u minus 12. Now please note that this u minus 12 and u minus 12 is common in both of them. So I could factor this out, u minus 12. If I factored out u minus 12, in the first term I would be left with u. In the second term I would be left with negative 6. Now that's what the factorization is. However, there is a little thing here. There is no u in the problem. U is something I have introduced here. So I must have to put back what u is equal to. I know my u is y square, so it's going to be y square minus 12 times y square minus 6. So that's what the factorization is going to be. So this is going to be y square minus 12 times y square minus 6. Now technically you could factor these two again using difference of squares formula. A square minus b square is equal to a plus b times a minus b. But I kind of don't want you to do that. Just leave it as it is. But just to show you, I'm going to do it here though. So y square minus 12. So this term, this factor, I could write it as y square minus square root of 12 square. And then the second term, y square minus 6, I could write it as y square minus square root of 6 whole square. Now I have a situation where I have difference of squares. So difference of squares, so it's going to be y plus square root of 12, y minus square root of 12, and then the second term or second factor, I could write it as y plus square root of 6 times y minus square root of 6, and that's what it is. But you don't have to go this far. Just so long you get to this point, that's good enough. I hope that this discussion was helpful. Thank you very much.